Section 1.8, guys, is officially, did you guys not get them? Okay, the notes. Okay. Section 1.8 is officially the last section of Chapter 1. So 2 weeks down and 1 chapter done already, which is pretty impressive. Okay, thank you. Oh, yes. So what we're going to do is actually the first time that we have variables thrown at us, which can be kind of scary. But what's the root in variables? The word vary, okay? So the reason why variables exist are because whatever number they're in place of, they can change, they can vary. And so instead of putting a 5, because it's a 5 and constant always, it can vary, all right? So the key thing here is we're going to evaluate them, meaning we're basically going to just substitute. What's it mean to substitute? Put it in its place, right? Like if you had a substitute teacher for my class, there'd be someone that's representing me as the teacher, okay? So let's look at example 1. They want us to take x minus 2. But they told us what x was. So what is x? 7. So we can just rewrite this expression, but we can write it as 7 minus 2. We just substituted our variable x, which was 7, in for x. All right? What is 7 minus 2? 5. Is that okay, guys? We always start out okay, right? And then it just gets more complicated. Okay, so let's look at example 2. We have 2 variables now, x and y. So the first move we're going to make is sub in x, sub in y, and then we've basically made a problem that we just did in 1.7, an order of operations problem, okay? So let's look at this. What is y that we're going to put out here?
4.
You guys see that, how it says y equals 4? Parenthesis, what is x? 8 minus 3. You guys see what we did? And at this point, guys, it's just an order of operations problem that we did 2 seconds ago, right? What are we going to do first? Are we going to do this multiplication first, or are we going to do the subtraction in the parentheses first? The parentheses, right? So what is inside the parentheses? 8 minus 3. What's 8 minus 3? 5. And what operation is this? This is technically multiplication, so it's going to be 4 times 5. Are you guys okay with that? And that will give us what? 20. So really, it's really similar to what we just did in 1.7. It's just we have that extra step of plugging the values in first, okay? So let's look at example 3. We have y plus 6 on top, where y is 18, all over x, where x is 6. Remember, whenever you have a big fraction bar like that, they want you to do the top by itself, the bottom by itself, and then divide at the very end. So what do we need to do first? 18 plus 6. So if you need to do 18 plus 6 over here on the side to figure what that out is, that's fine. 8 plus 6 is at 14. So 24, does that look okay? So the top is 24. Is there anything we need to do to the bottom? No, we just have to divide now, right? So how many times does 6 go into 24? 4 times. And again, if you can't get right there, do 6 plus 2, or 6 plus itself twice, 3 times, whatever you need to do. So this is 4. All right, guys, we're stepping it up. Number 4, we want 25 minus z. Anytime you have exponents, I typically put parentheses around it because it might have a negative. We haven't learned about negatives yet, but so z is what? 2, and we got to cube it, plus x, but what is x? 1. So notice I'm just mimicking the expression up there, but I'm filling in what I know z is and what I know x is. What are we going to do first? We're going to do this exponent first. What does 2 cubed mean? 2 cubed means 2 times 2 times 2, right? So what am I going to do first? 2 times 2, which is 4, but I can't forget to multiply by that last 2. So what is 2 cubed, guys? 8. So I'm going to go write this expression, but instead of 2 to the 3rd power, I'm going to fill it in with an 8. And then at that point, what are we going to do? Yep, subtract. We're just going to go left to right. I go over to the right. 25 minus 8, I like vertical subtraction, okay? I'm going to borrow from the 2, he's going to go to 1, he's going to go to 15. 15 minus 8, 7. 1 minus nothing's 1. So this is 17 plus 1, which is 18. But you guys see we just have that one extra step of plugging things in? and then it's 1.7. All right? Last one. Does anybody recognize this formula? It's okay if you don't. This is how you convert Fahrenheit temperatures to Celsius temperatures. So if it's 41 degrees outside, what is that in Celsius? You just plug it in. So we have 5 times F, which is 41 minus 32, all over 9. We're going to convert 41 degrees to whatever it is in Celsius. What do I need to do first? The parentheses on top, okay? So I'm going to do 41 minus 32 over here. I got to borrow, so it's 11 minus 2 is 9, right? So it's kind of hard to start writing these, isn't it? Okay. 5 times 9 over 9. Is that okay? My own work's going to kind of get in my way here, I think, okay? What do we need to do next? Clean up the top. I know you might see something, but we're not going to talk about that yet until we get into fractions. So what's 5 times 9? 45. But then what's 45 divided by 9? 5. What does that mean? It means 41 degrees Fahrenheit is actually only 5 degrees Celsius, okay? Because 32 degrees Fahrenheit is 0 degrees Celsius. Celsius is always smaller. Are there any questions on the front page? I feel like that was really fast. Are you guys good? All right, I like it. The next one is starting to get you actually kind of used to Math 112, okay? So Math 112 is elementary algebra. It's when you'll start seeing equations and having to solve equations and so forth. But the number one thing with solving equations is that you can always check your solution or check your answer. So even though they don't have us solving equations in this class, they want to show you that you guys have the smarts to check your equation, okay? So say this is an equation that your friend in elementary algebra had to solve, and they got 8 for their solution, okay? What does that mean? It means if we plug 8 in for y, this left side should equal the right side. So once we do all this math over here, if it equals 6, they found the right solution. If it doesn't equal 6, they've done the wrong thing, okay? So the real question is 3 times 8 minus 6 equal to 6? And I put a question mark there because I'm not saying it's equal. The question is it equal? Do you guys see all I did was take this supposed solution that they found for y and plugged it in? So it's what we were doing on the front page. It's just an application of it. All right, so what do we need to do first over here? Parentheses. What's 8 minus 6?
2.
So why am I putting 8? I don't know. 3 times 2, is that equal to 6, guys? Yes, 6 equals 6. So we would say, yes, it's a solution. So you'd pat your little friend on the back and say, good job. 8 is the answer for that. Do you have to solve that yet? No, but it's what they want you to start doing. Yes?
I just solved it and got 8.
Okay, and that's fine.
Yeah.
But if you have not solved equations yet, you can't do that.
So just do it like that then?
Yeah, make it
Okay.
easy.
Alright.
But that's absolutely fine because not everyone's had like algebra. So, but yeah, I think that's easier too, so you won't make mistakes moving things around and stuff like that. This, guys, is just making you do it 3 times. Okay, so they're being mean to us. They're making sure we can plug stuff in. Does 10 work? Does 6 work? Or does 8 work? Okay, so let's try 10 first. So I'm going to write that over here. 5 times 10 plus 4. Does that equal 34? Do you guys see what I did? I just took that equation over on the right-hand side, but instead of 5 in, 5 times the supposed answer. Okay? You guys see how I did that? What are we going to do first on the left-hand side? 5 times 10. What's 5 times 10? 50. So does 50 plus 4 equal 34? No, right? 54, and have you guys seen the symbol for? That's the not equal symbol, okay? I can't put it up here yet because I'm not too sure if it's not equal. So I'm like, question mark, is it? You know, but down here, so you'd say no, or however you need to say that. No to 10, right? 10 is not a solution. Then you're going to go over to 6, all right? So we'll do 5 times 6 plus 4. Does that equal 34? Exact same equation, right? But now instead of n being 10, it's n being 6. What's 5 times 6? 30. Does 30 plus 4 equal 34, guys?
Yes.
Yes. And at that point, you can basically stop. I mean, I shouldn't be telling you this. They do want you to still check 8, but what do we know about 8? It won't work. If we have one equation with one unknown and we found that unknown, we know 6 is it, right? 8.
The math lab will just have us put
That-
6 or 10?
Yes.
Okay.
So like once you find the right one, Caitlin, you're done.
Okay.
Okay? Because you guys don't have to see equations with 2 variables until Math 112. And that means there could be 2 answers. No, not this semester. No. All right, so here's what I think will be the difficult part or the more complicated part of section 1.8. It's taking English sentences and turning them into math sentences, okay? So basically, they want us to be able to write these based off of the words they give us, okay? So the first thing is, be careful with what they want you to use to represent a number. Like, we don't know, that's our variable. And they'll tell you, X is going to be our variable. Okay? Does it have to be X? No. It can be a Y. It can be a T. It can be a Z. It can be a cat face. I don't care. It's something to hold the spot of the unknown. But my math lab has to be able to grade it, so they want everybody to use the same variable. Okay? So what we're going to do is we're going to write these unknown sentences, but anytime you see the word a number, we don't know that number, so we're going to put it X, okay? So how do we show twice a number? What does twice a number mean? I'm twice your age, 2 times, all right? So does everybody agree that twice means 2 times? You can write that down, 2 times, right? So it's literally 2 times, right? 2 times what? A number. Do we know what that number is? No, so what are we supposed to put in? X.
Don't you just put 2x?
That's what I was going to go with, Stacy. So what I always do is I always like show all the operations first, so like word for word, you can see how the words match the operation. But like she said, a lot of times when you, let's rock out, a lot of times when you have a coefficient with a variable behind it, you don't usually show that dot, it's just 2x. So if I say the number is 10, you could tell me what twice the number was by plugging it in for x, right? 2 times 10 is 20, and that's the whole idea. It can vary. I said, oh, no, I didn't mean 10, I meant 4, guys. Well, what's twice 4? 8. You didn't have to change your whole expression, you just changed that variable. All right, how do we show 8 increased by a number? What's increase mean? What? Plus. We're going to add, okay? So start with 8. And what are we doing? We're increasing it by a number. Do we know what that number is? No. So what we're going to put? An x, right? And I can say, oh, hey, increase 8 by 10. It's 18. Or no, increase only by 2. Then it's 10. Your expression is able to stay the same as your variable changes. All right. This is where it gets tricky. Addition, it doesn't really matter what's first or last. But multiplication, or excuse me, division and subtraction, it does. So we have to be careful. This is 10 minus a number. What's minus mean? Subtract. And it's read that way. 10 subtract a number. So how are we going to write it over here? 10 minus our number we don't know is x. Is that okay, guys? I purposely picked D because look, it looks like it should be the same expression, but it's not. You have to pay attention to the wording. It's 10 subtracted from a number. So what's the order going to be there? X minus 10. So 10 minus a number is flat out telling you what to do. Take 10, subtract that number. But 10 subtracted from, when you're subtracting from, he's the guy in the back, right? So we're going to subtract from that number we don't know. We're going to subtract 10. Quotient means what, guys? Division. With division, they typically go in a row. Okay, what do I mean by that? Whatever they list first is your first number. So this is 6 divided by x. So the quotient of 6 and a number, or 6 divided by x like that. We did that in like 15 minutes. Are you guys sure that's not too fast? You promise? Okay.